Today, we will learn dimensioning methods, which will be completed through 4 sections. Review of previous knowledge. In the previous course, we learned about Chinese national standards for technical drawing, which includes drawing sizes, scales, fonts, line types, and their applications. Particular emphasis should be placed on mastering line types and their applications. Next, we will learn about dimensioning methods. Teaching and learning objectives. 1. Understand the basic concepts and purpose of dimensioning and clarify its importance in mechanical drawing. 2. Become familiar with the basic elements of dimensioning, including extension lines, dimension lines, arrowheads, dimension figures, and units. 3. Master common dimensioning methods. Dimensioning techniques such as linear dimensions, angular dimensions, radial dimensions, etc. Skill objectives. 1. Be able to select appropriate dimensioning datum and skillfully dimension part drawings. 2. Be able to possess the fundamental ability to dimension horizontal, vertical, and inclined features, as well as circles, arcs, spheres, etc. Attitude objectives. Cultivate rigor and precise drawing habits, and a serious, focused work attitude, and develop professional competence. First, basic rules for dimensioning. The shapes of the objects can be expressed by graphics, but the size must be determined based on the dimensions indicated on the drawings. Therefore, dimensioning is an important aspect for creating engineering drawings. A dimension is a numerical value expressed in specific units of length or angle, indicated on technical drawings using lines, symbols, and technical requirements. Basic rules for dimensioning. 1. The dimension figures represent the actual size of the part. It is independent of the drawing scale and the drawing accuracy. 2. Dimensions on the drawings are in millimeters. If other units are used, the unit name must be specified. 3. Dimensions indicated on the drawings represent the final finished size of the part. 4. Generally, each dimension of a machine part should be dimensioned only once, and should be placed on the graphics that best reflects the structure. Furthermore, when dimensioning, symbols or abbreviations should be used as much as possible. Common symbols and abbreviations are listed in the table below. 2. Elements of a dimension, including 3 key elements: extension lines, dimension lines, and dimension figures. Extension lines indicate the range of the dimension. They are drawn as thin, continuous lines. Dimension lines indicate the direction of the dimension. They are drawn as thin, continuous lines. The terminals of a dimension line are drawn as arrowheads or oblique strokes. In mechanical drawings, solid arrowheads are generally used as terminals of dimension lines. As shown in the figure, drawing arrowheads has specific proportional requirements. Avoid drawing overly thick, black triangles. Dimension figures indicate the actual size of the part, and are not related to the drawing size. Next, we will explain the requirements for each dimensioning element in detail. 1. Extension lines. When dimensioning, extension lines are generally drawn separately as thin, continuous lines, and are extended from the outline, axis line, or center line. Outlines, or center lines, can also serve as extension lines. Extension lines should generally be perpendicular to dimension lines. Inclination is permitted when necessary. When dimensioning at a smooth transition, the outline must be extended with a thin, continuous line, and extension lines are drawn from their intersection point. Additionally, extension lines should extend about 2 to 3 mm beyond the dimension line. 2. Dimension lines. Dimension lines must be drawn separately as thin, continuous lines. They cannot be replaced by other line types, nor should they overlap with other lines or be drawn on their extensions. Note: when dimensioning linear features, the dimension line must be parallel to the feature being dimensioned. Let's look at an example of incorrect dimensioning. As shown in the figure, the center line cannot be used as the dimension line for dimension 30, or the dimension line should not overlap with the center line. The dimension line for dimension 55 overlaps with the outline. The dimension line for dimension 35 is not parallel to the object being dimensioned. The dimension line for dimension 20 overlaps with the extension of the outline. The dimension line for dimension 22 is drawn on the extension of the center line. The corrected dimensioning is shown in the left figure. Also, when dimensioning circles, if the arc is greater than 180 degrees, the diameter phi should be used. For arcs equal to or less than 180 degrees, the radius r should be used. 3. Dimension figures. For linear dimensions, dimension figures are generally placed above the dimension line. They are placed parallel to the dimension line with the numerals oriented upward. Placed at the break in the dimension line is also allowed. Specifically, when the dimension line is horizontal, dimension figures are written above the dimension line, with the numerals oriented upward. When the dimension line is vertical, dimension figures are written to the left of the dimension line, with the numerals oriented to the left. When the dimension line is within the 0 degrees to 90 degrees range, dimension figures are placed in the upper left area relative to the dimension line. When the dimension line is within the 120 degrees to 180 degrees range, dimension figures are placed in the upper right area. When the dimension line is within the 90 degrees to 120 degrees range, this range is a 30 degrees restricted zone, or the black triangle zone. Direct dimensioning is strictly forbidden here. Dimensioning should be laid out as shown in figure. Furthermore, when dimensioning, smaller dimensions should be placed inside. Larger ones are placed outside. When dimensioning, dimension figures must not be crossed by any line, otherwise, that line must be broken. Standard fonts should be used for numbers and written neatly, instead of sloppily, on the same drawing. The size of numbers and arrowheads should be consistent. Besides linear dimensioning, there is also angular dimensioning. When dimensioning angles, the extension lines of the angles must be projected along the radial direction, reflecting symmetry from the center. The dimension lines should be drawn as arcs. Its center is the vertex of the angle. Angular dimension figures are always written horizontally and generally placed at the break in the dimension line arc. When necessary, they can be placed above or outside the arc, or indicated as laid-out figures. 3. Common dimensioning methods. 1. Dimensioning of circles, arcs, and spherical surfaces. The terminal of dimension lines for diameters and radii should end with arrowheads. When dimensioning diameters, the diameter symbol phi should be added. When dimensioning the diameter of an arc greater than a semicircle, its dimension line should be drawn slightly past the center, with an arrowhead pointing to the arc at only one end. When dimensioning the radius of an arc equal to or less than a semicircle, the dimension line is drawn from the center towards the arc, with only one arrowhead. The radius symbol r should be added ahead of the dimension figure, and the dimension line must pass through the center. When the radius of an arc is overly large, or the center position cannot be shown within the drawing limits, a break line can be used for dimensioning. When it is unnecessary to show the center position, the dimension lines should be drawn only on the segment closest to the arrowhead. When dimensioning the diameter or radius of a spherical surface, the letter S should be added ahead of the diameter or radius symbol. That is, for spherical diameter, S phi is added ahead the figure. For spherical radius, SR is added ahead of the figure. 2. Dimensioning small-sized features. For small dimensions where there is insufficient space between extension lines for arrowheads or for writing dimension figures, dots or oblique strokes can be used instead of arrowheads. When dimensioning a series of small features, small dots or oblique strokes can replace arrowheads. The size of the dot replacing an arrowhead should match the width of the arrowhead's tail. However, arrowheads should still be drawn at the two outermost ends. When diameter or radius dimensions are small, both arrowheads and figures can be placed outside the arc. 4. Simplified dimensioning. In the same drawing, for repeated features like holes or slots with the same size, their size and quantity may be indicated on only one feature. Use the abbreviation EQS to denote equally spaced. When the location and distribution of the features are clear from the drawing, their angular dimension can be omitted, and EQS can also be omitted. When dimensioning the thickness of a plate-like part, the thickness symbol T may be added ahead of the dimension figure. To sum up, this course has covered the basic principles of dimensioning, the elements of dimension, common dimensioning methods, and simplified dimensioning. The key is to master the significant points for the three elements of dimension. Wish you success in your studies.